Are you interested to evaluate Murata's Wi-Fi and Bluetooth combo modules, but not quite sure exactly which one is the right fit for your design needs? Well, Future Electronics, Murata, and Embedded Artist have partnered together to create an RF bundle kit for their leading Wi-Fi and Bluetooth combo modules to help developers minimize time, space, and effort required for their most ambitious innovations. Hi, welcome back to TechVentures. My name is Lazina, and I'm a technical marketing engineer at Future Electronics. If you're interested in checking out any previous TechVenture videos, then please click the link on the screen or check out the description box below. What exactly is the Murata RF bundle kit? Well, this is a one-of-a-kind solution, which is exclusive to Future Electronics, facilitates an easy out-of-the-box customer development experience showcasing Murata's new and formidable Wi-Fi and Bluetooth modules on an NXP and Infineon-based development platform.
The bundle consists of the following: an Embedded Artist i.MX 8M Mini Developers Kit version 3, 6 M.2 modules, of which 3 are based on an NXP chipset. So we have modules types 1XK, type 1ZM, type 1YM, and the other 3 are Infineon-based chipsets. The modules are types 1YN, type 2AE, and type 1LV.
Today, I'm going to walk you through how to get started.
Let's open the big box. You'll see that there are 2 other boxes inside. If we open the big box, this is where you'll find the i.MX 8M Mini Developers Kit. The other box contains accessories. The M.2 modules look like this. For today's tutorial, I'm going to use the Type 1XK. The steps in today's tutorial are applicable to the other M.2 modules in the bundle. We need to mount it on our i.MX 8M Mini Developers Kit. This slot here is for the module. Insert it like so and secure the module with the screw. Next, we will power on our board. Connect a USB cable from your laptop to over here and the power supply over here. And we're going to slide the power button on. There should be a few green LEDs illuminated. Next, open your serial program of choice. Mine is TerraTerm. Make sure you enter the appropriate settings for the serial port. You will be presented with a login prompt. Enter the login credentials as listed on the screen to log in. First order of business is to configure our system for the mounted M.2 module. We need to select a device tree file to use, select the appropriate libraries to use, and we need to set up configuration files, system services for automatic connection to a Wi-Fi network, and configure which geographical region the hardware is being used in so that it complies with local regulations. There are 2 scripts to facilitate what I just described. The first script is shown on the screen. This will select the device tree file, configure libraries and utilities, and enable the correct system service based on which M.2 module will be used. If we run the script without any parameters, we will see the full list of available module names. To enable your M.2 module, type the command shown on the screen followed by the name of your module. In my case, since I chose type 1XK, I will put 1XK. Next, we will configure the geographical region so that the hardware is being used in compliance with local regulations. Enter the command as shown on the screen. The command will return the various options available. Select the one that is applicable for your region. This script limits the available frequencies to match the requirements in the specified geographical region. Next, we need to tell our system which Wi-Fi network to connect to. This information is stored in the WPA supplicant configuration file. Open a text editor, such as VI or Nano. I'm going to use Nano, so we'll enter Nano followed by the file location of the configuration file in the prompt. Replace the part marked in the red rectangle as shown in the screen with the appropriate SSID and password of the network you are attempting to connect to. Enter Ctrl X to save and exit the editor. If you are prompted to save, say yes. At this point, we need to reboot the system so the changes can take effect and our module is detected properly. Type in reboot into the prompt. Once the reboot is complete, enter the login credentials again. Once we're back into the system, we will check to see if the WLAN interface is up. So enter ifconfig mlan0. If you're using an Infineon-based chipset, then you would enter the same thing I just said, but instead of mlan0, you would put WLAN0. Everything looks like as it should be, so now we can go on to the next step. We're going to scan for available Wi-Fi networks using the command on the screen. And if you're successful, you should expect to see the list of Wi-Fi networks available. Now let's test our network connection with the ping command. This command can go on for ages, and we can always terminate the application with Ctrl-C. Success! As we can see from the ping statistics, there was 0% packets lost, which is great in my book. This concludes the Wi-Fi setup, and now let's move on to Bluetooth. We can bring up the Bluetooth interfaces with the command shown on the screen. If you receive an error message, don't be alarmed, it's okay. These messages can appear for NXP-based chipsets and can be safely ignored. We can scan for other Bluetooth devices in range with the HCI tool scan command. Similar to the Wi-Fi scan command, the list of advertising Bluetooth devices are printed.
There are so many more commands to tap into Bluetooth and Wi-Fi's full potential. For a complete guide on these commands or on how you can qualify to receive a free RF bundle kit, please feel free to reach out to your local Future Electronics representative or visit us online at futureelectronics.com. Thanks for watching, and I'll catch you next time on TechVentures with Lazina.